All right, this is topic 45, second derivative test. So, assuming you have a function whose derivative at this point is 0, okay, remember that if the derivative at this point is 0, that means that you could either have a max, a min, or just something that looks like a cubic function, right? So at that point, we don't know anything other than that we have a horizontal tangent on function f at this point. Now, however, if you combine that with the fact that the second derivative is positive, right? Remember, if the second derivative is positive, that means you have a concave up shape. Okay, so if at this point, at point C, you have a horizontal tangent, and also at that same point C, the second derivative is positive, then that means it's concave up, right? Which means at that point right there, that's going to be a local min. At this point right here, you would have a local min, all right? So similarly, if the derivative is at point C is equal to 0, and the second derivative at C is negative, that means if the second derivative is negative, that means you have a concave down shape. And if you have a concave down at the same point at which the first derivative is 0, then you have a local max. All right, so hopefully that makes sense. So on example 1, it's given to us that we have this critical value. So remember, critical values means that you can have a derivative that is equal to 0. Those are the values where the derivative is equal to 0 or undefined. However, because we took two derivatives, that probably means that the derivatives are equal to 0. Okay, so we have that f of x. These are the critical values right here for f of x. So remember, at that point, you could have a minimum or maximum or neither. You don't know that, all right? So, and they also give you the second derivative, which is this one, all right? And they're asking you to determine if any of the critical values are local extrema. So I'm trying to figure out if they're minimums, maximums, all right? That's what I'm trying to figure out. So it's actually very simple. What you would do here is, because of this right here, that means that if I have a critical value at -1, and I plug that into my second derivative, right, my second derivative being 4 minus 12x squared, but instead of x, I'm going to plug in a -1. And when I do that, I get the answer as -8. Now, the number is not really that important, except for the fact that this is a negative number, all right? So if I have a critical value at -1, and my second derivative at -1 is a negative number, and therefore, remember, if I have a negative number, that means it's going to be concave down, which means I have a maximum. So therefore, there's a local max at x is equal to -1. All right, so we're going to do the same thing on the other one for the next couple, all right? So I'm going to plug in the second derivative. I'm going to plug in a 0 for x on the second derivative. And that's going to give me a 4. And 4 is a positive, right? So that means I'm concave up, all right? And if I'm concave up, that means I have a local minimum. And finally, I'm going to do exactly the same thing on the next one. So I'm going to plug in a 1 into the second derivative. And that's going to give me a -8 again. So that means that at 1, I also have a concave down, which means I have a local max. All right, so hopefully you're making that connection here, that if at some point, if at a critical value, the second derivative is positive, all right, if the second derivative is positive, then you're going to have a concave up shape, which means you have a local min. And if you plug in, if we have another critical value, and at that critical value the second derivative is negative, then you're going to have a concave down, which means you have a local max. All right, so let's look at example 2. It's very similar to the next one. We're going to plug this critical values into the second derivative, and then figure out if that's going to be positive or negative. So in this one, I get that this is equal to 0, right? Now, so this one right here, because it's equal to 0, there's really not much I can say other than I can't determine I can determine the local extrema using the second derivative test. So you don't have enough information for you to make that call according to this, all right? All right. So if I plug in the next critical value, which in this case is positive 2, I still get the same thing. And if I get the same thing, well, if it's 0, it's not a positive value or a negative value, so therefore, I also cannot determine whether I have a local extrema using in the second derivative test. Alright, let's go to the back here, and we're going to see some interesting correlations, I guess, and interesting relationships. Alright, so we know that an even function, alright, and I'm just going to give you an example of something that looks like this. An even function, say, looks like this. Right, hopefully from our knowledge of pre-cal, we know that this is going to be symmetric around the y-axis. Alright, the concavity is going to be the same, and by the same I mean around the line of symmetry, which is this, the concavity is the same. By that I mean if this is concave up here, this side is also going to be concave up. Remember, the line of symmetry is right here, right? And if this is concave down here, well, this is also going to be concave down. Alright? And then the increasing and decreasing part, well, they're going to be opposite. Alright, so this is actually really good to remember. However, I normally don't try to memorize this because I think if you make sense of this, oops, this is decreasing and this is increasing at this point. If you make sense of this, you don't have to memorize anything. Alright, so an odd function, kind of like a cubic, if you will, or a symmetric around the origin, right? And the concavity is going to be opposite around the point of symmetry. So notice that right here you're concave down, and right here you're concave up. Right? So that's going to be opposite, and it's going to be increasing and decreasing. This is going to be the same. Okay, so if you need to look at these longer, just press pause. I'm going to keep going. All right, next example 3. All right, we don't know what the function is, but all this information is given to us. All right, so I do know that it's an odd function. All right, I do know that. So really, it's going to follow this. It's going to follow this exactly. Okay, now say that you didn't know that. All right, and I'm going to pretend like I don't even know this. All right, what I like to do here is just kind of try to set up a table if I can. Right. It's telling me, remember, this is f of x I'm looking at. So f of x is 0. If x is 0, f of x is 0. Right, if I go between 0 and 1, it's positive, so that means that there's y values are all going to be positive here. At 1, I'm at 2, so 1, 2. Okay. And then between 1 and 2, let's see, this x is equal to 2. I'm still positive, but at 2, I'm 0. And if I'm anything over 2, I'm somewhere down here, like, you know, the y values are going to be negative. That's what that means. All right, so I'm going to connect the dots. Remember, this is positive, positive, and it just kind of keeps going that way. All right. Now remember, this is an odd function. So if this is an odd function, this is going to be symmetric around the origin. All right. So if this is going to be symmetric around the origin, then it's going to follow the same pattern as the last one. But it's going to be symmetric around the origin. All right, so that's what that looks like. You can kind of look at this and be able to tell what's going to happen here, right? So notice it right here for f of x. Now all of these are going to be opposite. All right, so notice that at between 0 and negative 1, all those values are going to be negative. Okay, notice that right here at negative 1, you're going to have a y value of negative 2. Right, so all of these are going to be opposite. Between negative 2 and negative 1, let's see, negative 1 and negative 2 right here. All right, all those values are still going to be negative. at negative 2 is still going to be 0. All right, it's going to be 0 right there, and after that is going to be positive. So again, notice that this is actually the same. It's following this pattern, I'm sorry. All right, notice that this is going to be positive. All of these are opposite right here. All right. The concavity, notice that it's telling me the concavity is going to be the opposite. All right, right ahead. So we already know that. But let's take a look. Okay, so I'm sorry, the concavity. Let's go to increasing and decreasing. Notice it's the same. So if you notice that, you can be like, well, I know it's going to be the same because my teacher told me to. Hopefully that's not the reason. So positive, negative, 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 negative. All right, so please notice how this is like a mirror image here, right? They're a mirror image, so it's not quite. I'm not just going to write exactly this over here. All right, so it's like a mirror image here. And for the second derivative, the concavity is going to be opposite, right? So this is the second derivative. Let's talk about concavity. So again, if you look at this, hopefully it can make sense. If it's less than negative 2, this is going to be concave up, so this would be positive. All right, at negative 2, I'm still positive. Between negative 2 and negative 1, still positive. At negative 1 is right here, still positive. Between negative 1 and 0, between here, still positive. All right, notice that right here it says that that's 0, and that would make sense because right here I have a point of inflection. I switch concavities, all right? So notice that all of these were exactly like we said they were going to be here, okay? Now, let's take a look at an even function. Again, you can draw yourself a picture if you want, or just have that other stuff memorized, either one. I prefer to kind of draw myself a picture. I don't really like to memorize a whole lot of things, okay? All right, so on this one right here, we're actually starting on the negative side. I'm going to plot this point. So we have, let's see, 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. So I'm going to draw this graph here. We know that at negative 2, I have a positive 3. At negative 1, I'm at 0. And at 0, I'm at negative 2. All right, so that's what I know so far. All right, notice that right here, if I go down the line though for, let's see, for this one right here, I have a change of concavity here also, but we'll get into that later. Notice that right here, between negative 2 and negative 3, I'm positive, so I'm somewhere up here. All right, and at less than negative 3, I'm negative. So more than likely, I kind of did that right there. Okay. Now if you know that, you can know that this next side is going to, since this is going to be an even function, it's going to be symmetric around the y axis. So this is basically going to be the same here, right? This is going to be a mirror image. So notice again, if you look at, this is going to be exactly the same, right? Because notice that's a mirror image. So right here, just kind of do it from this side out. So we're going to have a negative here, or you can just look at the graph. We have 0, positive, 3, positive, and then finally negative. Okay. So that's what we got. In terms of increasing and decreasing, they're going to be opposite. But again, if you can tell, you can go for here between 0 and 1. Notice that you're increasing. Well, I guess I should put positive here. And then, let's see, at 1, right here, I'm still positive. I'm still increasing. Right? And then, but again, they're going to be the opposite, all right? So it's going to be positive, positive, positive. That's going to still be 0. And then we have negative, negative here. Again, if you can't tell that, then go to those points between 2 and 3. 2 and 3 is right here. Notice that I'm decreasing between 2 and 3, right? All right, finally for concavity, all right, concavity should be the same, all right? So, however, let's take a look at it anyway. Notice that you have a point of, what do you call it, inflection here. but the concavity is going to be the same, all right? So notice that between 0 and 1, there's going to be concave up, which makes the second derivative positive. All right, at 1, I'm still concave up, so this is positive. Excuse me, that's 0. Yeah, so right here, remember I have a point of inflection, so the second derivative is going to be 0. All right, after that, notice that between here and here is going to be concave down, which will make that negative. Okay, let's see, where am I at here now? Positive, 0, negative, and then negative the rest of the way. Because it's going to have the same concavity, right? So again, you can either look at the picture or just try to memorize this if that makes sense to you. All right, if you got any questions, make sure you ask me tomorrow. We're about one lesson away. We'll cover one more lesson before our next test, all right? Good luck.